Just give me 5 minutes. I'll start in 5 minutes.
Okay, sir.
Hi. So yesterday we were discussing about ellipse, right? And I suppose we have completed ellipse as well. Just give me a moment. Give me 2 more minutes. Okay, I'll participate in 2 minutes. Hopefully you are able to see my screen, right? Do you guys try to solve problems from NCRT book? Yeah, you guys are there. You're listening.
Yes, sir.
Am I audible to you guys?
Yes,
Yeah.
sir.
Okay. So yesterday we were doing ellipse, right? And we saw standard equation of ellipse. Uh, okay. So it's standard of what is standard equation of ellipse? Hari? Yes, Hari. So what is standard equation of ellipse? Can you hear me or not?
Can you hear me, sir?
I can hear you now. Yes, tell me. What is standard equation of ellipse? Huh?
X square into a square, sir.
X square upon a square.
Upon x square, sir. Plus y square upon b square, sir.
Then what is then
equal to 1, sir. Is equal to 1.
is equal to 1. Yes. So this is standard equation of ellipse. So here A is your major axis and B is your minor axis. And another equation, when here A is greater than B, x square upon A square plus y square upon B square is equal to 1. If B is greater than A, the ellipse will look like this. So this is this ellipse and this is this ellipse. Okay.
Sir.
Yeah. Of course, this is x and this is y. This is y, x. Okay. And this distance is B. And this is A. Okay. And here, of course, this one is A. This is A. Okay. Understood? And eccentricity in this case, E is equal to square root of 1 minus B upon A whole square. And here in this case, E is equal to square root of 1 minus A upon B whole square. Okay. So this is how we can find the equation of ellipse. All right. So let's go to NCERT book exercise. What exercise? 11.3, right? 11.3. Solve problem from here. Okay, so 13. Solve problem number 13. Here, edge of the major axis is given. So major axis. Edges are plus or minus 3, 0, and foci is plus or minus 4, 0. How you will find it? So sorry, foci is wrong. Foci is 0, plus or minus 2. Okay. Yeah. How you'll find it? Yes, sir. See, the major axis is on x-axis, right? This is x and y, isn't it? That means the ellipse, the equation of ellipse is x square upon a square plus y square upon b square is equal to 1. Okay. Where a is your major semi-major, that means a is greater than b here, isn't it? Now, accordingly, a will be equal to 3, isn't it? A is equal to 3, it is given. So what will be b?
0, sir. 0, sir.
Why b is, how can b be 0? Yeah, b can never be 0. How can b be 0?
2, sir.
2, why it is 2? See, this is a wrong problem, I think, in the book. NCERT book, this is right. Can you turn on page number 255? Just check if this is the problem. Ends of major axis is plus or minus 3, 0. Ends of minor, minor axis, it's not focus. Okay, so this is minor axis. Okay, so minus is 0, that means b is equal to 2. So what will be the equation of ellipse?
X square by 9 plus y square by 4, sir. Is equal to 1.
Is equal to 1. So this will be the equation of ellipse. Easy it is, right? It is very easy, isn't it?
Okay, sir.
Yeah.
Sir,
See,
yes.
okay, I'll give you one problem. So minor axis is given, ends of minor axis is plus or minus 5, 0, and foci foci or foci, whatever you say, it is plus or minus 3, 0. Find the equation of ellipse. How you will find it? How will you find this one? See, it's minor axis is given, right? See, whenever we draw any ellipse, minor axis is on x-axis, isn't it?
Sir.
Minor axis is on x-axis. So
Yes,
this
sir.
is, we are talking about this ellipse, because y-axis is the major axis here. Okay, so this is the ellipse. Now what else is given? So minor axis is plus or minus 5, 0. That means this point is given 5, 0. This point is given minus 5, 0. That means B is equal to 5 given. Okay, sorry, A is equal to 5, right? Because it is on X, it is A, 0, no? And this is minus A, 0. That's why A is equal to 5. And this is semi-minor axis. Okay. All right. What else is given? Foci. Foci is given plus or minus 3. Just a minute. See, sorry. Foci cannot be like here. It is 0, comma plus or minus 3. All right. So in this case, foci is plus 0, 3, and here 0, minus 3. And what are the focuses? S1, S2. What is the coordinate of a focus? S1 is, means S, let's say S is the focus, so its coordinate is plus or minus AE, 0. Or in this case, because A is semi-minor axis, so S is 0, plus or minus AE. That means AE is equal to 3 given. That means E will be equal to what? 3 upon 5. Eccentricity you have got. You got eccentricity, you got the value of A. Can you find the value of B? So B, how you'll find? We know E is equal to square root of 1 minus A upon B whole square, because here A is smaller than B. Okay. Therefore, you can write E square. Sorry, 1 minus E square. Yeah. You can write A upon B whole square will be equal to 1 minus E square. Okay. That means A upon B will be equal to square root of 1 minus E square. So from here, we need to find the value of B. So this will be equal to A upon square root of 1 minus E square. So A will be how much? A is already given 5. Square root of 1 minus E is how much? 3 upon 5 whole square, right? So you substitute it. Tell me the value of B. How much will be B? So just solve this one. 5 upon 25 minus 9 square root of this upon 5. So this will be 25 upon 4. 25 upon 4 is your B. So the value of B is 25 upon 4. So A you have got, B you have got. So equation of ellipse will be x upon A square. X upon A is 5. So 5 square upon y, sorry, x square, y square upon B square. So 25 upon 4 whole square is equal to 1. Okay. That means equation of ellipse will be x square upon 25 plus 16 y square upon 125 is equal to 1. Or you can also write this as x square. See, this is 20 x square plus 16 by 5y square is equal to 25. These are the methods you can write the equation of ellipse. Okay, understood? Am I going too
Yes.
fast?
No, sir. No, sir.
Okay. So let me know if you are, so solve this problem. Understand what is minor axis, major axis. When it is given minor axis, see for this type of ellipse. So ellipse on y axis, okay? So the focus will be on y axis, right? Focus is on y axis. See, for this type of ellipse, y axis, focus is here, S1, S2, let's say, and major axis is here. That means B is the major axis here, okay? So focus will be 0, comma, B, 0, comma, minus B. Sorry, BE, and this endpoints are, that means endpoints are 0, comma, B, and this is 0, comma, minus B. Okay, this point is minor axis, so 0, A, comma, 0, and minus A, comma, 0. So for this type of ellipse, A is lesser than B. Eccentricity will be equal to square root of 1 minus A upon B whole square. See, always remember this thing, this value should be less than 1, because if it is greater than 1, then it will be square root, right? Square root of -1, so it will be a complex number. We don't want that. So it is A upon B because A is smaller. So this A upon B will be less than 1, right? So this is this type of ellipse. Now when ellipse is on x-axis, okay, like this. So if ellipse is like this, now you see this is your major axis, x-axis is your major axis, okay, and y-axis is your minor axis, y, x. Now the endpoints if you write, so this is your A, comma, 0, this is minus A, comma, 0, this is 0, comma, minus B, this is minus 0, comma, B, this is focus S1, let's say this is S2. So focus S is AE, comma, 0. Here it is minus AE, comma, 0. Got it? Now this lattice rectum here is this one. These are the two lattice rectum here and here. Okay. These are the directrix. Okay. This and this will be the directrix. So equation of directrix is x is equal to A upon E, sorry, minus A upon E, and this is x is equal to A upon E. Okay. Lattice rectum, equation of lattice rectum is what? X is equal to, it is passing through point what? AE. So x is equal to AE. Here it is passing through, x is equal to minus AE. Okay. That will be your lattice rectum. Understood or not? Huh? See, in this case, these are the lattice rectum. This and this is the lattice rectum, and this will be your directrix. So equation of directrix, if you write, what is this? Y is equal to B upon E. Y is equal to minus B upon E. Lattice rectum, equation of lattice rectum will be Y is equal to minus BE. Y is equal to BE. Okay. Understood? Now, how do you find the endpoints of lattice rectum? This point, how you will find? What you can do here, you can connect this point S, let's say this some point P, this is some point P, and this is S. So connect S1 P S1 to P. Now you are getting a triangle. We are getting a triangle. From here, let's see the triangle. Okay. This is a triangle we are getting, right angled triangle. Right. So this is S1, S2, and P. We don't know the coordinate of P, so let's write XY. S1 and S2 we know. S1 is how much? AE comma 0. S2 is minus AE comma 0. Right? But we know this is 90 degree. Right? Yes. Huh? Are you listening? Now see, any point on ellipse will satisfy the equation of ellipse, which is x square upon a square plus y square upon b square will be equal to 1. Okay. So point P is on the ellipse. Okay. It can be some point, we don't know. All right. Are you getting it or not? Yes, sir. Anyone, please reply. Am I audible to you guys? No. See, what will be the value of x here? This x. What is this x? How much will be this x? Huh? This x will be equal to AE because it's a vertical line, right? You see here, this is a vertical line. That means the whatever the value of x is here, the same value of x is here. So x is AE, but we still don't know y. Why we don't know. How we can find? We will substitute here in this equation. Okay. So let's substitute it. So x is AE square upon a square plus y we don't know. So y square upon b square is equal to 1. We need to find the value of y. Okay. So this will be a square and a. So we can write a square e square upon a square plus y square upon b square minus 1. A square will cancel. So y square will be b square up into 1 minus e square. Okay. So y will be equal to square root of, or you can write b 1 minus e square. So that will be the coordinate of what? Y. Isn't it? Yes or no? Tell me if it is correct or wrong. Now we also know that eccentricity, e square is equal to 1 minus a square upon b square, right? So instead of e square, we can write a square upon b square is equal to 1 minus e square. So we will again substitute it here. So what we'll get? Y is equal to b multiplied by what? A upon b whole square root of a is something is wrong, something is wrong, something is wrong. Okay, so I think till this part it is fine. Till this part it is fine. Okay, so what do we know? E is equal to square root of 1 minus b upon a whole square. Okay, so 1 minus e square is equal to b square upon a square. If we substitute it here, what will get? This will get b multiplied by b upon a, right? So this will be b square upon a. Okay, so the end point, so the coordinate of point P, the coordinate of point P will become AE comma b square upon a, b square upon a. That's what we have got. Yeah, b square upon a. Now, if this point is P, let's say if this point is Q, end of lattice rectum. So what will be the coordinate of Q? it will be AE, comma, minus B square upon A, because it is in the downward side. Okay, you're getting it or not? Am I going too fast?
No, sir.
Are you able to understand
Yes, sir.
why it is P is AE, comma, why is P AE? Why is this AE?
X is AE, sir.
Why it is AE? Can any one of you explain why it is AE? See, it's really simple. If this is XY curve, if you draw a straight line on this point, whatever the value of X is constant here, right? So same value of X will be there throughout. So here X is equal to 2, then here also X is equal to 2, right? Y, the value of Y is changing, but the value of X is not changing. Can you see this? Yes or no? So same thing. Now see here, the coordinate of S we know. So vertical line, if you draw, it will intersect the ellipse at P and Q. That's why the X coordinate of P is AE, and also the X coordinate of Q is AE, because the coordinate of its this point S2, the focus, second focus is AE. Okay. Now since the focus lies on x-axis, y coordinate is 0, and we have calculated the y coordinate of point P is B square upon A. Okay. Similarly, because it is in the it is in the first quadrant, that's why it is positive. Now if you move to fourth quadrant, it will be minus B square upon A. Understood? Similarly, we can find for this one as well. Okay, so can you find that one? See, same thing will happen for this ellipse as well. You just join a line from focus, say this triangle. Okay, right angle triangle. Anyway. Okay. Solve question number 20. Exercise 11.3. Question number 20. Done. See, major axis of the x is on the x-axis and passes through point 4, 3 and 6, 2. Okay, so this is a different problem. Is given that the ellipse is on x-axis. Okay, the major axis of the ellipse is on x-axis. All right, so ellipse is this. This is the ellipse they are talking about. Okay. Okay. Now it says that, okay, major axis. So we don't, and nothing, no other information is given. It's just given there are 2 points. Some point P, which passes through point 4, 3, and a point Q, let's say like this, which passes through 6, 2. How you will find the equation of ellipse? How you will find the equation of ellipse? These 2 points are given. See, what is the equation of this ellipse? General equation of this ellipse. This is A, if this is A, and this one is B. What will be the equation of this ellipse? Shri-Kruti, what will be the equation of the ellipse?
Sir, x square by a square plus y square by b square is equal to 1.
Which one is greater, A or B?
Sir, a is greater than.
Okay, now A is now these 2 points lies on this ellipse, right? So point P will satisfy this equation. Point Q will also satisfy this equation. So plug the value of P and Q in this equation and find the value of A and B. So do that. Plug the value of P. P is what? 4, 3 in this ellipse. So what you will get? 4 square upon A square plus 3 square upon B square is equal to 1. Now again plug the value of Q. Q is 6, 2 in this ellipse. What you'll get? 6 square upon A square plus 2 square upon B square is equal to 1. Tell me the value of A and B. Or A square and B square. You calculate the value of A square and B square. That's it. Do it fast. See, 2 equations. You are given 2 equations. Equation 1 and equation 2. And you have 2 variables, A and B. Find the values. How much you are getting A? Or A square, how much you are getting? Please do it fast. Yes, Hari, how much you're getting A square and how much you're getting B square?
B square I got is 13, sir. Is that right, sir?
Okay, B square you are getting 13. And A square?
Doing, sir. Wait, sir.
Yes, Shri-Kruti, you got the answer?
52, sir. Is it 52, sir?
How much?
52, sir. A square.
52. Okay. So this is correct. So what will be the equation of ellipse?
X square by 52, sir.
52, yes.
Plus B square by 13.
Or Y
Sorry,
square.
Y square by 13. Y square by 13 is equal to 1, sir.
Yeah. So this will be your equation. See, simply, if you don't know how to solve this one, reciprocal, you just multiply this. Okay. 4B square plus, sorry, 4 not 16, no? 16B square plus 9A square is equal to A square B square. So this is your equation 1. 2 will be 36B square plus 4A square is equal to how much? A square B square. Fine. Now you can solve it. Now it is easy to solve. So you can just do like that if you are not comfortable. Okay. Okay, let's solve another problem. So hopefully you'll be able to solve all the problems on ellipse. Huh? Okay. Okay, I'll move ahead. Let's move to our last conic section, that is hyperbola. Okay. So before that, you solve one more problem here. Solve this problem. Okay, so the foci or foci, whatever you say, is 2, 3 of the ellipse. Okay. Plus or minus 2, 3. Semi-major axis is given. The length of semi-major axis is square root of 5. Find the equation of ellipse. Done. Now see, the foci is given plus or minus 2. That means foci is on x-axis. Right? That means S1 is plus 2, 3. S2 is minus 2, 3. Okay. So the ellipse is like this. This is your S1, S1. Oh, sorry, S2, this one, and this one is S1. Doesn't matter. The length of semi-major axis is given. That means this length is given to you. This is the axis. Let's say this is X. This is your Y-axis. And this value is B from here to here. And this length B is equal to root 5 is given. Now what? So these are the information given to you. You know, focus is plus or minus AE, 0. Right? But you don't have the value of A. Right? You don't have the value of A. You don't have the value of E. Right? But you have the value of B, that is square root of 5, isn't it? So what is the length? S1, S2 is how much? S1, S2 is 4, which is equal to what? 2 times of AE, right? And that means AE value is how much? AE value is 2. You don't even need this one. You don't need this one. So if you compare these two, you will get AE is equal to 2. Let's say this is equation number 1. We know B square is equal to A square times 1 minus E square. And we know the value of B, right? So can we substitute B here? B is root 5. So A square into 1 minus E square is equal to 5, isn't it? So this is equation 2. Solve 1 and 2, find the value of A and B. 2 equations, 2 variables. How you'll solve it?
Sir?
Yeah.
Sir, semi-major axis means it is A, right? Not B.
No. See, semi-major, see this, for this ellipse, this is semi-major axis. Okay, so semi-minor axis it should be, no? I'm sorry. This is my mistake. This is semi-minor axis. Yes, you are right. You're right. This is semi-minor axis. Root 5. The value of b is given, that is root 5. Yes, correct. Thank you. Yeah, solve this equation number 1 and 2 and tell me the value of this. How you will solve it? So you multiply this. So what you'll get, a square minus ae whole square is equal to 5. Now the value of ae we can substitute from equation number 1. So a square minus 2 square, that is 4, is equal to 5, right? So value of a square is equal to 9, a is equal to 3. The value of a we are getting is 3. So what will be the value of e? We don't even need the value of e because we need to find the equation of ellipse. So standard equation is x square upon a square plus y square upon b square is equal to 1. So x square upon a square value is how much? 9 plus y square upon b square value is how much? 5 is equal to 1. That will be the equation of ellipse. Understood? Okay. Let's move to the last conic section, that is hyperbola. Okay. See, hyperbola is exactly same, not same, I won't say same, but the definition is exactly same as ellipse, but eccentricity is greater than 1. Okay. Eccentricity is greater than 1. For ellipse, eccentricity is lesser than 1. Okay. So for any conic section, let me write the definition again. Okay, so a hyperbola is defined as the locus of a moving point. That means a point is moving in space. So this is a fixed line, and this is a fixed point, let's say S. Okay, and a point P is moving in space. Let's say here, somewhere around here, or here, let's say here. Okay, point P is here. So if you join this line, this is P. So if we join PS and we draw a perpendicular line on the directrix on this fixed line from point P. Okay, let's say this point is M. So the ratio is a constant. PS upon PM is a constant which is called eccentricity, which is greater than 1. So PS is always greater than PM. Okay. So point P is always closer to directrix. The fixed line is called directrix, and the fixed point is called focus. Okay, focus. Yes. So the point point P will move such that it will always, this ratio will be greater than 1. Okay, that is what is called hyperbola. Okay, now again, of course, it is some part of a cone. So to understand hyperbola, we have to draw two cones, two inverted cones. Right circular cone will draw. Okay, because hyperbola is a part of a conic section. Okay, now this is the axis of this is the axis of these two cones. This is the axis, vertical axis. This is axis of cone, not hyperbola. All right. Now, what's the definition? What did we learn in the first class? See, this angle of cone is alpha. So this is also alpha, 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 alpha. Now, if you slice it in such a way, if you slice in such a way, let's draw. Okay. If you slice it in such a way, so now you are slicing it, the axis of this plane is, it makes angle beta. Okay, it makes angle beta wherever it intersects the cone. So this is beta. Okay, this angle is beta. Now, what should be the value of beta for it to be a hyperbola? Remember, in the first class we learned this. What should be the value of beta? See, beta should be lesser than alpha. Okay, if beta is less than alpha, then it will always intersect as a as hyperbola. Whatever the section that it is intersecting will be hyperbola. Okay, so beta, and of course beta has to be greater than 0, then it will be hyperbola. Okay, now let's understand what hyperbola is. Let's see a standard equation of hyperbola. See, in your syllabus you don't have general equation of hyperbola or general equation of any conic section, but there is one equation from which you can define all hyperbola, parabola, ellipse, circle, everything. You just need to substitute the value of E. Okay, we'll see that at the end. I'll just give it to you if you want to use it. Equation of hyperbola. Okay, so general equation of hyperbola is x square upon a square minus y square upon b square is equal to 1. So this is your hyperbola. Okay, now here b square is equal to a square into e square minus 1, where e is your eccentricity greater than 1. So e square will be equal to 1 plus b square upon a square, right? Eccentricity. All right. Now, in hyperbola, we don't say major axis or minor axis, because hyperbola is an open structure. Ellipse is a closed structure. We'll see how. Let's draw a hyperbola. So we'll be drawing, we'll be sketching this hyperbola. Okay, this one. Y, X. Now the hyperbola, it is like something similar to parabola, but it will be in both sides. Okay. Now the vertical axis, this vertical axis is called conjugate axis. Okay, this is called see, this is y axis, but point B. Let me first write it down. So this is the vertex A. Let's say this is A. Its coordinate is A comma 0, and let's say this is A dash. Coordinate is minus A comma 0. So here, this axis is called transverse axis. A is called transverse axis. Let me write here A. Okay, and let's mark B. So B is here somewhere. Let's say B, it is 0 comma B, and B dash 0 comma minus B. Okay, B is called conjugate axis. Okay. So if it will have directrix as well, right? Isn't it? Let's say this. This is the directrix. This line is this line, this line. Let's say this is the directrix. Okay. So what will be the coordinate of directrix? Equation of directrix. So x is equal to minus a upon e, and here x is equal to a upon e. So this will be the equation of directrix. Latus rectum. So first let's write down the focus. So this is the focus F, or S. We are writing S as focus, right? So let's say S1 or S, whatever we want. We can, let's write S. S is AE comma 0, and so here it will be S dash minus AE comma 0. Okay. Now the chord that passes through focus and is perpendicular on the axis is called latus rectum. So these two are the latus rectum. What will the equation? Or it is, so end points of latus rectum. Let me write down. So ends of latus rectum, this, and this. P, Q, R, and let's write R dash. So PQ, this will be AE comma B square upon A. This will be AE comma minus B square upon A. I'll show you how we get it. I'm just drawing it, that's why I'm writing it here. So minus AE comma B square upon A. Like in ellipse we calculated, in a similar manner we can calculate it here. Minus B square upon A. Okay. So that's how this line. Okay, let me write down all everything one by one. Okay, so all the parameters one by one. So foci. So focus is S. There are two focus, S, that is AE comma 0, and S dash, which is minus AE comma 0. So this is the focus. Second one is equation of directrix. Equation of directrix. So this is x is equal to plus or minus A upon E. Vertices. It will again have two vertices like ellipse. So this is A comma E, or you can write plus or minus A, E. Because A is this point, A dash will be minus negative. So D is latus rectum. Okay. So equation of latus rectum is x is equal to plus or minus A, E. Two latus rectum we have. So this is equation. Length of latus rectum. Length of latus rectum is equal to 2b square upon A. Okay. All right. Now ends of latus rectum already we have written. How to calculate, we already we will see that how to calculate. Okay, there are several properties related to focus and the center, but we are not going to again cover all those properties here. Okay, so let's solve some of the problems based on this. How do you find the endpoints of this, like point P, Q, point P, point Q? Okay, I think it is getting too much. So E, let me write E here somewhere. E is equal to square root of 1 plus B upon A whole square. Okay. So in case of ellipse, this is minus. In case of ellipse, this one is plus. That's the only difference, right? Now ellipse is a closed structure and hyperbola is an open structure. Okay. Hyperbola is really important if you are studying astronomy. Okay, because the planetary system or the satellites, they move in hyperbolic coordinate systems. Okay, so right now we are only studying rectangular coordinate system, which is x, y, z. There are parabolic coordinate system, hyperbolic coordinate system, and all. Okay, so we'll see that. No, matlab, not here, of course, not here. You will learn that. Similarly, you can have a hyperbola in this shape. Okay, so you can calculate all those values from there also. We'll see that, but not today. Let's solve few problems on hyperbola. Okay, so exercise 11.4. See, eccentricity of hyperbola is always greater than 1. Remember that. Okay, so the equation of hyperbola is given to you. X square upon 16 minus y square upon 9 is equal to 1. Okay. Find the coordinate of foci. Find foci, vertices, eccentricity, length of lattice rectum. Find out. If for reference, just check out these values. So how you'll solve it? You guys done? Okay. So first we need to find focus S. What is this? AE comma 0, because you see x. Now first always write down standard equation of hyperbola. What is that? X square upon a square minus y square upon b square is equal to 1. Now you see from this above equation, a is greater than b. Okay, that means this hyperbola is on x-axis. Okay, so the transverse axis is a and b is conjugate axis. All right, so let's find out. A is equal to 4 and b is equal to 3. Now from here we can find eccentricity, that is equal to square root of 1 plus b upon a whole square. Okay, so square root of 1 plus b is how much? 3 upon 4 whole square. Okay, so this will be equal to 5 upon 4. That will be your eccentricity. Okay, eccentricity we got. Now focus S is given by C, AE comma 0, plus or minus AE comma 0. So S will be equal to, the focus will be plus or minus A is 4 into 5 by 4 comma 0. So this, from here we can write focus is plus or minus 5 comma 0. Okay. Now what else? Equation of directrix, right? Now vertices. Vertices means A and A dash. That is plus or minus A comma 0. So that will be A plus or minus A is how much? 4 comma 0. Okay. A, and what else we did? Length of lattice rectum. So that is 2b square. Length of lattice rectum will be 2b square upon A. So 2 times of 9 upon A is 4. So this will be 9 by 2 unit. Got it? So that's how you will calculate all the values. Now you see the biggest difference between ellipse and hyperbola. See, for ellipse, first thing, this value here it is positive. Eccentricity here it is negative. Okay, that's the difference. Now in ellipse, see, S focus is 5 and this major axis, when you are finding in ellipse, it is greater than focus wherever focus is, right? That means in ellipse focus is inside, right? But in case of hyperbola, focus is here. That means away. Okay, it is also inside only, but it is away more, and this point is your transverse axis. Okay, transverse axis. But in case of ellipse, this point is A, right? A, this is minus A, and this is AE, minus AE and AE. Okay, so you will always find S value smaller as compared to A in ellipse, but not in hyperbola. Same thing here. A is greater than S in ellipse. Okay, and opposite in hyperbola. Okay, so more we'll discuss on hyperbola. Next class we will finish hyperbola as well. Okay, so thank you so much for joining mathematics class. Thank you.
sir.
See, you can solve that exercise 11.4. I think you'll be able to solve using these values. Okay, just try it. You'll be able to solve it.